Good morning, friends. Now today we will see how can we obtain a truth table from a given Boolean function. Now there are two cases. Either we are given with a standard canonical SOAP form or a simple SOAP form, or in second case we are given with a standard canonical pause form, or you can say that simply pause form that may be canonical or not, and we have to obtain a truth table for these functions. Okay, now let's see by an example how can we obtain a truth table from SOAP form. First is example 1. Let us suppose the function is, that is case 1, given function is your standard SOAP form. Okay, suppose the question is, that is obtain the truth table for FABC is equals to A bar, B bar, C bar plus A bar, B bar, C plus A, B bar, C bar plus A, B bar, A, B, C bar. Okay. Now, for this function, let's have consider the individual mean term first. This is your M1, this is your M2, this is your M3, and this is your M4. Okay, let's consider first this. This mean term will be 1 if A is equals to 0, B is equals to 0, and C is equals to 0. Similarly, second mean term will be 1 if A is equals to 0, B is equals to 0, and C is equals to 1. Likewise, for the same mean term 3, that is, this will be 1 if A is equals to 1, B is equals to 0, and C is equals to 0. Okay, and for the last mean term, that is A, B, C bar, this will be 1 if A is equals to 1, B is equals to 1, and C is equals to 0. This gives that if any of the combinations exist for this function, okay, then function FABC is equals to 1 if any combination from this means this list satisfied. Okay, or you can say that any of the mean term will gives you 1. Now, as this given function is considering 3 variables, so let's draw the truth table for this 3 variable Boolean function. A, B, C are the inputs, and let's suppose the function is this one. So possible combination says there are three inputs. The possible combinations are, number of possible combinations are is equals to 2 raised to power 3, that is 8, and these should be ranging from 0, 0, 0 to all ones. Now the function will be 1. This function, output function, will be 1 if we get a is equals to 0, b is equals to 0, c is equals to 0 for mean term 1. It means at this position. Second, the function will be 1 if a is equals to 0, b is equals to 0, c is equals to 1. It means this one. And for this third term, that is if a is equals to 1 and b is equals to 2 and c is equals to 0, that is this one. And the fourth is when a is equals to 1, b is equals to 1 and c is equals to 0, that is this one. Okay, and rest of the, for rest of the inputs, the function will gives a 0. So this is the complete truth table. Okay, in this way, if we represent this function in terms of its mean terms, then if we write its decimal values, then this is your decimal 0, 1, 2, 3, 4, 5, 6, 7. So the same function, that is f of ABC is equals to a bar, b bar, c bar plus a bar, b bar, c plus a bar, b, c plus a, b, c bar can also be written like this. Summation small m with the mean terms at this one, this one, this one and this one. 0, 1, 3 and 6. It means for these cases the function will give you the output 1. This implies that SOAP form will always gives 1 as output for any of its mean terms. Okay, that is in as in above case, that is at 0, at 1, at 3 and 6. Okay, now let's take another example in which standard SOAP form is not given. Our SOAP form is given. Example 2 of case 1. Suppose given function is f a b c is equals to AB plus BC. Okay, this is not a standard SOAP form. Standard means canonical. Okay, so convert this standard SOAP form into, convert this non-standard SOAP form to standard SOAP form, that is canonical form, or you can simply use this method as AB has a value either has a value 1 1, for which this f will be 1. Okay, so there are two possible cases for C here, because C is missing in this case. Either C can be 0 or C can be 1. So the two terms we will get here is, that is a mean term M6, because this reflects your decimal value 6, and mean term 7. Similarly, for this BC, in BC A is missing. Okay, and for BC the values must be 1, for the function f of ABC should be 1. So for the missing variable A, this should either be 0, this can either be 0 or can be 1. So there are two terms here. Again, this is your mean term M3 for decimal value 3, and this is your mean term for M7. So the truth table will be again the same. You can see here the function, above function f of ABC. Which function I am talking about? This function can also be written like this, that is summation M 0, 6 and 7. No need to repeat 7 two times, because the 7 at this position and 7 at this position are same. Okay, so the truth table will be 1 for these mean terms. Okay, let's see, that is A, B, C, and function f okay. So 0 1 0 1 0 1 0 1 0 0 1 1 0 0 1 1 0 0 0 0 1 1 1 1, and this function will be 1 only for these values, that is 0, 6 and 7. Okay, so 0, 6 and 7. At rest of the combinations, for rest of the combination, the function will be 0. Now case 2. Case 2 is, suppose standard POS form is given. Okay, let's have an example. F A B C is equals to A plus B bar plus C and A plus B bar plus C bar and A bar plus B plus C bar and A bar plus B bar plus C bar. What are these terms? These are your max terms. Okay, all these are actually max terms. And this is your max term first, this is your max term second, this is your max term third, this is max term fourth. So let's find the function's value for mean term first, that is A plus B bar plus C is equals to, that is, if this will be 0 if A is equals to 0, B is equals to 1 and C is equals to 0. Okay. Similarly, second mean term, that is A plus B bar plus C bar. This will be 0 if A is equals to 0, B is equals to 1 and C is equals to 1. Similarly, for the third term, that is A bar plus B plus C bar. This will be equal to 0 if A is equals to 1, B is equals to 0 plus C is equals to 1. Similarly, the fourth term, if A bar plus B bar plus C, it means if A is equals to B is equals to C is equals to 1, all the terms are 1. If we draw the truth table for this, sorry, there this should be 0 here. If we draw the truth table for this, then A, B, C and the function f zero one zero one zero one zero one 0 0 1 1 0 0 1 1 0 1 0 0 0 1 1 1 1. Okay, so the output will be 1 for this combination, sorry, output will be 0 for this combination, that is, if A is equals to 0, it means at this combination. Second output will be 0 for A0 and B is equals to C is equals to 1. That is for this combination. Okay. I did a mistake here. Okay. Now, similarly, the third term, that is 1 0 1, the fourth term this. Okay, and rest of the cases the output will be 1. So we can say that this function f(abc), which is given here, this can also be represented as pi with decimal values, for which this is the function is 0, that is for this 2 3 5 and 7. 2 3 5 and 7. 2 3 5 and 7. Okay, and this is the same function which is yeah, this is the same function which is represented above, that is this one. Okay, this is the same function. You can also represent it like this. Now if we want to represent the same function in terms of SOAP form, this is actually your standard pause form, and we want to represent this in your standard SOAP form. Okay, then we have to choose these values, that is 0 1 4 6. Okay, this is 0 1 4 6, and it represents the same function, or you can say that same truth table. Okay, now let's have an example with a simple SOAP form. Pause form. Simple pause form. Suppose the function is f a b c with a plus b, okay, into b plus c. Here you can see that c is missing, so you can write it like this: a plus b plus c bar, and here a is missing in second term, so a bar plus b plus c. Okay, using the Boolean theorem, that is this one, a plus b plus c bar for this first term. Okay, similarly for second term, this is a bar plus b plus c into a plus b plus c for the second term. So finally we can write this is equals to, because these two terms, that is this one, sorry, let's take another color, that is this one and this one is same, so you can combine them. A plus b plus c into a plus b plus c bar into a bar plus b plus c Here this will be 0 for a is equals to 0, b is equals to 0, c is equals to 0. This term will be 0 for a is equals to 0, b is equals to 0 and c is equals to 1, and this will be 0 for a is equals to 1, b is equals to 0, c is equals to 0. So in this way this function f abc is equals to pi, because this is 0 0 0, that is 0 0 0 1 1 1 0 0 4. Okay, thanks for watching this video.